In this video, we're going to look at example 4, graph the reciprocal function. So how do you graph the reciprocal function y equals 1 over x? What we're going to say here is that the reciprocal function maps every non-zero real number to its reciprocal. And one of the first things we want to look at is in terms of domain and range. So if I'm looking at 1 over x, I want to ask myself what numbers can I use for x? All right, well, we can't have a 0 in the denominator. So my domain is going to be, we'll say all real numbers, or x cannot be equal to 0. So let's write it this way. So x, where x cannot be equal to 0. All right, so again, if you have an x there in the denominator, right, we have an undefined expression. So x cannot be equal to 0. Everything else is okay. Fractions, decimals, negatives, any other number that you can think of will work. Now, on that same line, when we look at the range, this we need to do a little more thinking. And we need to kind of think, all right, what are some possibilities, or what would be impossible to happen for my y value? Well, the only way, or looking at this graph over here, what I'm also going to realize is that y cannot be 0 either. Right, because there's no possible way for me to plug in a number as my x value and somehow make 1 over x equal to 0. Right, it's impossible. I'm not going to be able to do that. So my domain and my range are pretty simply that x cannot be equal to 0 for the domain, and the range y cannot be equal to 0. Now, I want to talk a little bit more in generalities in this. The graph here, it looks a little different than any other graphs we've seen. But what's going on is this is going to keep going up here. You know, this is going to keep going to the right. This is going to keep going down, and this will keep going left. All right, what's going to happen is this specific graph is never actually going to cross the x-axis or the y-axis. And when we talk about that, that's something called an asymptote. So that's a line that a graph approaches, but asymptotes guide the end behavior of the function. So if I'm looking, again, at this part here, or if I follow this curve, it's not perfect, but you get the idea. What's going to happen is this graph is going to keep going up, it's going to keep going right. So that asymptote, let's get rid of that. That asymptote is actually the x-axis. Right? It guides the behavior. So going off to the right, my graph, that red line, is going to keep getting closer and closer and closer to the x-axis, but it's never actually going across it. And the same idea on this left side is that it's going to keep going. So we're looking at over here now. This is going to keep getting closer and closer and closer to x-axis, but it's never actually going to touch the x-axis. So that's what an asymptote is where your graph gets closer and closer and closer, but is never actually going to approach this. And if you were to make a chart of actual x values and plug in numbers larger and larger and larger, you know, like 10, then 100, 1,000, 10,000, you'll realize that you're never going to actually get 0. But the numbers themselves, where you have y equals 1 over x, those numbers themselves are going to keep getting smaller and smaller. So what does all that mean? What this tells us is that this x-axis, which is the line y equals 0, is a horizontal asymptote. All right. And I'm writing that in blue, where that highlight is in blue. So it is the x-axis, but we'll say the equation for the x-axis, right, is y is equal to 0. Now that same idea applies along the y-axis. So as I'm going up further and further here, my function or my graph is going to get closer and closer to the y-axis, but it's never actually going to touch it. And then on the bottom, as I'm going lower and lower, as I'm approaching that negative infinity, again, it's going to get closer and closer to the y-axis without actually ever touching it. And what that tells me is that in this case, x equals 0 is a vertical asymptote. And again, these are kind of just talking generalities here. In the next example, when we get to example 5, we'll use a little bit more of a specific example, and you'll kind of see what's going on there. We talk about some shifts in the graph where it could go left or right, up or down, but you'll see that these asymptotes, think of them as like boundaries. All right, your graph will just keep getting closer and closer and closer to it, but it'll never actually touch that asymptote.